Okay guys, today we are going to get started on our Unit 1, and we are going to start with remembering our Pythagorean theorem and applying it to distance on the coordinate plane. All right, so let's start here. If we are thinking about Pythagorean theorem, let me get to my there we go. If we are thinking about Pythagorean theorem, what do we remember? Let's use our notes over here to help us out. First thing, do you remember that it's a squared plus b squared equals c squared? And that it only applies to right triangles. The longest side is called the hypotenuse, and it is always labeled C in the Pythagorean theorem. You'll always find it across from the largest angle. For example, over here in our warm-up triangle, this is a right triangle because I have a slope that is undefined and a slope that is 0. And whenever you have that situation, it creates a perpendicular intersection, which means it's a right angle. Okay, now what about the other two sides? The other two sides are called legs. Now, when you use the Pythagorean theorem, does it really matter? Well, A stands for our altitude, which is always perpendicular to the base, and B stands for base. But let's take a look at this triangle again over here. Here's my altitude. This is my base. But if I were to rotate the same triangle, just let's say turn it to the left, well then my altitude would be what it's sitting on and would become the base, and the base would become the altitude. So it really doesn't matter. As long as you're not using the hypotenuse. Either side could be the altitude and either of the others could be the base. So now it says find the lengths of all three sides of the triangle below, round to the nearest tenth. Well, we can count that this one is 5 units. Just U for units. And this one is 10 units. But what about C? So I can use my Pythagorean theorem. Simplify. Well, this is still c squared. I don't want c squared, I want just c. The opposite of squaring a number is to take the square root, so I have to do that on both sides. Now I have, this does simplify to 5 square roots of 5 equals c. So exactly 5 square roots of 5 units, but it says to round to the nearest tenth. So when I put 5 square roots of 5 into my calculator, and now I'm going to round to the nearest tenth. So this is going to be approximately equal to 11.2 units. This would be exact. Sometimes you're asked for exact form, and it always has the radical still in it. And once you move away from that, you're in an estimate. Okay, so find the distance using the Pythagorean theorem. Let's move this to the coordinate plane. I have a group of trees here, or a tree here, and the car is here. What is the distance between these 2 points? It's a diagonal, and on the coordinate plane, any diagonal can be used to create a right triangle. I can count the units for my base and my altitude, plug them into the Pythagorean theorem, and then I would say that it's exactly root 74 units, or approximately 8.6 units. Okay, what is a polygon? It is a closed figure. I think of it as having, like width sides. So in other words, no curves. And how do you find the perimeter of a polygon? Perimeter equals the sum, means you add them together, of all side lengths. Thing about length, it's the same thing as distance on the coordinate plane. The length of B is the same thing as the distance from each endpoint. So now what is the perimeter of the triangle for our warm-up? Well, remember, this was 5, this is 10, and this was 5 root 5 exactly. So I can say that my perimeter is 5 plus 10 plus 5 root 5. Now I can simplify. I can either say it's exactly, perimeter is equal to 15 plus 5 root 5 units, or perimeter is exactly equal to 5 root 5 plus 15 units, or I can say it is approximately equal to, and take my 5.5 and use its decimal value and say that the perimeter is approximately equal to 26.18 units. And if it told me to round to the nearest tenth, I would say 26.2 units. So that's a review of perimeter. For area, let's think about the area of a rectangle formula. So if I have a rectangle, this is my base and my height. Height. My area is base times height. Now when I think about a triangle, all I have to do is think about, if I were to draw a diagonal in, it would create two congruent triangles. So that's why every triangle is base times height divided by 2. That's going to be the area of a triangle. The area of the triangle from the warm-up, our base was equal to 10, our height was equal to 5. Remember, the height or the altitude of the triangle is always perpendicular to the base. I'm just going to say that the area is 10 times 5 divided by 2. Area is 50 divided by 2, which is 25 units squared. All areas are two-dimensional, so it's always going to be in units squared. Now, before I move on to the next slide, I want us to think about this diagonal we have here. What is the slope? We talked about the slope of the horizontal line being 0 and the slope of the vertical line being undefined. But what is our slope here? Remember, it is our rise over our run. Another way of thinking about that is our altitude or our height over our base. Let's think about that as we now move on to our distance formula. Sometimes you don't have the coordinate plane, and we want to think about this formula. This right here is our run. This right here is our rise. So when we think about this in terms of the Pythagorean theorem, we can think about distance as the square root of our run squared and our rise squared. And it really doesn't matter which way you use it. So let's take a look at these two right here. If I were to connect them, make that diagonal, remember I can make a right triangle off of this. 1, 2, 3. 3 equals my height. 1, 2, 3, 4, 5, 6, 7, 8 equals my base. My distance at this point, it doesn't matter if I do the 8 first or the 3, but I'll put it in as my run plus my rise, square root of, I have to keep everything under the root. So now this is the square root of 73, which does not simplify units, and this is exact, or is approximately 8.5 units. Let's look at a few others. Now here we do not have the coordinate plane. We have point Q, which I would label as x1, y1, and R is x2, y2. Now again, I could have made this my second point and this one my first one. Does not matter. If I'm following the distance formula, I'm going to set it up like my little Pythagorean theorem. A squared plus b squared, take the square of it, and it gives me my diagonal, which is the d. Okay, x2 is a -6 minus a -2. y1, or y2 is 1 minus y2, -4. Now think about your double negatives here. This is the same as -6 plus 2, which is going to be a -4 squared. And then plus, this is the same thing as 1 plus 4, so I'm going to have 5 squared. 16 plus 25, 41, and this units is exact form, or I can say my distance is approximately equal to 6.4 units. And that's just rounded to the nearest tenth. Okay, you pause the video and try this one. When you come back, let's see if you can give it to me in what it exactly equals and to the nearest hundredth. Okay, how did you do? If you made any errors, check your integers and then come back and try it again. Okay, now I want you to try these. I'm going to tell you they all come out nice and even. Go ahead and pause the video. And give it a go. When you come back, check your work. Okay, now that you're back, hopefully you have them all correct. If not, feel free to jot down a few questions and ask those in class. I'm going to stop the video now. In the next video, I'm going to discuss finding the area. This is what's up next. The area using the box method. Guess what it involves? Drawing a box. All right, guys. See you in the next video.